Hi everyone, Assalamu alaikum. Welcome to Exam Essentials. Today is the big day, your Edexcel IAL Physics Unit 5 exam. Today, in this quick revision session, I will cover the key concepts, formulas, and tips you need to cover to ace the papers. Stay focused and let's ensure you walk into the exam room with confidence. So, without wasting any more time, let's get started. Okay, so today we will go through the gravitational potential and gravitational potential energies. Now you guys might ask me why you are showing us this thing just before the exam. So the reason is there is a question regarding gravitational potential and gravitational potential energy, which is really common in our Edexcel Physics Unit 5. So before completing that question, we will complete and derive the formula that we will be using in order to solve that question. Right now, let's get started without wasting any more time and solve this type of a question. Let's say this is our Earth, okay? And this is the orbit at which a satellite will orbit the sun. A satellite will orbit the earth in this. So let's say this is our satellite and this is the orbital in which it will orbit the earth. So if we write the center of the earth, let's say this is the center of the earth. From the center of the earth, this is the radius. Let's say this is our r, which is the radius from the center of the earth to the surface of the earth. This is the surface of the earth. This is the surface of the earth, and this is the orbital. Let's say this is the orbit. Okay. Now, from the surface of the earth, the satellite was at first in the surface of the earth. This satellite was at first in the surface of the earth, but then it was taken into a height h meter above the surface of the earth. H meter above the surface of the earth. So now it's around h meter above the surface of the earth. This is h. So if we calculate the distance this satellite has gone is from the surface of the earth is 1 r plus h. So that means it has gone a distance of r plus h. It has been taking to a distance of r plus h. So this blue line is r plus h. This is the distance. This is the radius away from the earth. This is the radius the satellite is away from the earth. Now let's derive the formula of gravitational potential energy. We know del U means gravitational potential energy. Gravitational potential energy is gravitational potential into mass. So del V into mass, sorry, my bad. Del V into the mass. This is the formula of gravitational potential energy. Okay, gravitational potential into mass. Now the gravitational potential has a formula of minus gm by r into mass. This will be the formula. Now you guys might ask me right now why the gravitational potential is negative right here. Why the gravitational potential is negative? The reason behind the gravitational potential to be negative is because at infinity, let's say it is at infinity. It is at infinity. And infinity we say gravitational potential is 0. At infinity the gravitational potential or gravitational potential energy is 0 at infinity. But the orbit at which the satellite will be orbiting is not at infinity, right? So it is not that much far away from the earth. So it is at negative potential. That's why it is at negative potential. This is the main reason behind it being at negative potential. Anything below the infinity part, anything below means anything in this part, anything in this part from the infinity is negative. If you can cross infinity or if you can reach infinity, at that time your potential will be 0. Before reaching the infinity, your potential or potential energy will always be a negative value. That's why it's a negative value. So let's now move forward and don't waste any more time. Now if I can derive the formula, U is equals to minus gm m by r by combining them two. Okay, now this is the formula. This is at the this is at the surface. This is the potential at the surface. This is the potential at the surface. This is the potential at the surface that we have derived right now. Now we have to draw for the orbit. Now we have to draw what is the potential, or what is the gravitational potential energy at the orbit. Now the gravitational potential energy at the orbit will be minus gmm divided by r plus h, because this h is also included, because you are r plus h radius away from the surface of the earth, from the center of the earth. That's why the formula will be like this. So this is the difference between them. Now we have to, if I have to change, or if I have to figure out, if I have to figure out the change in gravitational potential energy of the satellite when it has moved from the center of the earth to the to this orbit, if I have to figure out the gravitational potential energy, if I have to figure out the change in gravitational potential energy as this satellite was first in this part and then later on move on to the orbit, what is the change in gravitational potential energy? The change in gravitational potential energy will be del u is equals to u final minus u initial. Now u final was at the orbit and u initial was at the center of the earth, or at the surface of the earth. So u final is at the orbit, which is minus gmm by r plus h minus this value, minus gmm divided by r. So this minus minus becomes a positive value, so it is minus gmm divided by r plus h plus gmm by r. If we derive this formula and bring something into common, it becomes plus gmm by r minus gmm by r plus h. So this is the formula which will be really important for you guys today, because I'm more or less, I'm sure, or I think that this type of question will come today. So now, as we have derived this formula and we have understood it completely, now let's go and solve a question together using this formula. Come on, let's go. in this question they have written what they have written. Let's go through the question right now again. They have written the dashed circle on the diagram represents gravitational equipotentials about the planet Mars. The gravitational potential at x and y is given. The gravitational potential at these 2 points are given. Meteor has a mass of 250 gram. Okay, this is an indication that we have to use the formula of gravitational potential energy. We know del V means gravitational potential is equals to GPE divided by mass. Okay, gravitational potential energy per unit mass is the gravitational potential. So they have asked in our question change in gravitational potential energy. So we can say our del GPE is equals to mass into del V. Okay, mass into del V. So they have asked which of the following is the change in potential energy as meteor falls from y to x. So at y and x, so we have to minus these two gravitational potential energy. So first of all we can figure out the gravitational potential energies, which is given as gravitational potential of this. So what we can do is they have the same mass but the V is different. This V is different. One is this and the one is this. So what we can do is we can write del GPE is equals to mass of del V means let's say x minus y. Del V means the potential at x minus y. So we can write it down as x minus y. So here m into minus 5.5 mJ minus 3.7 mJ. We can write it down like this, and this mass will be 250. So 250, it will become 250 into minus 1.8 milli per kg. So the answer will come out as minus 450. So our correct answer will be this. The correct answer will be C. Here at actually it will not be y minus x, it will actually be x minus y. My bad, it will not be x minus y, it will be y minus x, because y is at greater potential. Y minus x. So minus 5.5 joule minus 3.7 joule. So this is how we will do them. Okay, right now we have got minus 450. And now another thing that I want to make you guys understand, though it is not written in our question, but I still want to make you guys understand, is why is this gravitational potential energy negative? The gravitational potential energy is negative because the gravitational potential at point x is more negative or at a lower point than y. It is at a lower point than y. That's why it is more negative, meaning the meteor is moving to a region of stronger gravitational potential, means closer to the planet's surface. This indicates that a meteor is losing potential energy as it falls. It is losing the potential energy as it falls. Since the meteor is moving towards a lower potential, it has a lower potential than it. This loss of potential energy is represented by negative value. As it has a higher potential and it has a lower potential, the meteor is moving from a higher potential to a lower potential. So this loss of potential is shown by the loss of potential energy, which is represented by a negative value. That's why it is important to understand why the gravitational potential energy is negative. That's why the negative sign reflects the decrease in gravitational potential energy as the meteor falls towards the planet. It is moving from a higher potential to a lower potential, so its gravitational potential energy is decreasing as it is going from a higher potential to a lower potential. That's why we are showing gravitational potential energy by a negative sign, as the gravitational potential energy is negative because it is coming from a higher potential to a lower potential. Done. Right, in this question number 4 they have written a satellite of mass m is on the earth's surface. Okay, very good. A satellite is moved into a circular orbit of h above the earth. Okay, so let's say this is the earth, this is the center, and the satellite was at this position at first, which is 1r, and after that it was moved to a height of h. It was moved to a height of h above the earth's surface, above the earth. Okay, the mass of earth is m and the radius of earth is r. Okay, which of the following gives the change in gravitational potential of the satellite? the change in gravitational potential energy of the satellite when this satellite was moved from this position to this position. Okay, what is the change in gravitational potential energy? We know gravitational potential energy, the formula of gravitational potential energy is, U is equals to minus gmm by r. This is the formula, right? This is the formula of change in gravitational potential energy. Okay, now I'm not going to derive this formula today. I'm not going to derive because this derivation is very basic and it is in your book. If you haven't learned this derivation, then please go to your book and learn the derivation, or go to your notes that you have studied. And the other thing is, if you haven't learned the derivation, please let me know in the comment box. I will make a separate video for derivation. Now we know gravitational potential energy is equals to minus gm by r, and now some students have a question why there is a negative sign right here. I'm going to explain that thing. Okay, the gp is negative here. The gp is negative because gravitational forces are attractive. And the reference point u is 0 is taken at infinity. Let's say at here in the infinity the u is 0, and if at infinity the u is 0, then anywhere between here, or even here or here, the gp will be negative. The u is 0 is at infinity. Let's say it is an infinity. Infinity means it is very away from the center of the earth. At infinity the gravitational potential energy is 0, but anywhere in between the infinity and the earth's surface, the gravitational potential energy is said to be negative. That's why we have put a negative sign right here. So in this position at the surface, we can say, in this position the gp is said to be u is equals to minus gm m by r, right, in this position. But when it was taken into height h, at that time the gravitational potential energy will be minus gmm by not this radius, because now the radius is with this r, now the radius is along this r plus this height, so it is r plus h. This is the value, right? Now if we have to find the change in gravitational potential energy, this is the gravitational potential energy at the surface of the earth, and it is the gravitational potential energy at the height h to which this satellite was moved. Now if we have to find the change in gravitational potential energy, we have to subtract the final value with the initial value. Now what we can do is minus gmm by r plus h minus gmm by r. So this minus becomes a positive value. So minus gmm by r plus h plus gmm by r. So what we will do right now is we will write it plus gmm by r minus gmm by r plus h. So basically this is our correct answer, B. This is how we will derive the question number 4. Now, alright guys, so let's solve this internal energy question together, because this is a very important question for the January 2025 candidates, because this is the question that might come in your January 2025 exam. I am predicting that I will provide this type of questions too. I will provide two this type of questions which you guys should go through before your exam tomorrow. So let's read this question and do it. Okay, so air is used to inflate a balloon. The inflated balloon has a volume and contains this number of particles, and it has a volume of this. Okay, this has a pressure of this, and they have asked us to find the average kinetic energy of the molecules. When they will say average kinetic energy, we will straight jump onto one equation or one formula, which is half mc squared is equals to 3 by 2 kt. This is the formula. Now they have asked us to find the average kinetic energy. So we know half mc squared is our average kinetic energy. So we can write it down as average kinetic energy is equals to 3 by 2 kt. This half mc squared is our kinetic energy. So we can say kinetic energy is equals to 3 by 2 kt. This is average kinetic energy, my bad. Average kinetic energy is equals to 3 by 2 kt. Now we know 3 by 2 k is a constant. Now we just have to find out the temperature in Kelvin, which will give us the average kinetic energy. Now, in order to find the temperature, we have to use the formula PV is equals to NKT. This is the formula which we will have to use. In this PV is equals to NKT, NK is a constant. So we can remove that part because it will not change the value. Okay. Actually, K is the constant which we don't need to take into consideration, but we can write this formula like this, that temperature will be equal to PV by NK. Okay, we have got the pressure as 1.15 into 10 to the power 5 into volume as 1.77 into 10 to the power minus 3 divided by the NK. We have got the N as well, which is 5.15 into 10 to the power 22 into the K value. The K value is constant, which you need to memorize, or you can find it in the last part of the question paper, minus 20 by 3. So this is how we will get our temperature. Our temperature will be 286 Kelvin. Now we can use this temperature value to put right here to get the average kinetic energy. So 3 by 2 into K is 1.38 into 10 to the power minus 23 into this 266 Kelvin will give us our average kinetic energy. So the average kinetic energy will be 5.93 into 10 to the power minus 21 joule. So now we are done with this question as well. Now let's move forward to another question relating to this formula, which is highly important for your exam in the January 2025 and May 2025, because these type of questions are very common, and it may come because it came in the October 24 paper as well. All right, so let's start solving the question number 11. Helium gas can be used to fill balloons. Okay. The cylinder of helium gas contains this number of molecules. Okay, this is the number of molecules. The temperature of the gas is 293 Kelvin. Okay, calculate the internal energy of the helium gas. So this is quite a different type of question, which wasn't that much common in the previous question papers. It's a very different question to the ones that always come in our physics unit 5. So October 2024, this is a different question, and for the January 2025 candidates, this question will be really easy, and I will suggest you guys to revise page number 123 to 124, these two page from the physics student book, 123 and 124, because that will be very important to understand this internal energy part. Though this question is just a 2 marks question, but you never know, maybe in the January 2025 or May 25 session, this question might be a handy question, or a bigger question might come from this concept, which I hope you guys, I am more or less sure that you guys are not familiar with, because these type of questions are not that much common in our unit 5. So let's solve this question. They have asked about the internal energy. And we know there is only one formula which relates the internal energy. That is half mc squared is equals to 3 by 2 kt. The formula is half mc squared is equals to 3 by 2 kt. This is the formula. If I break down this formula, we know the average kinetic energy of any molecule in a gaseous sample. So they are talking about the internal energy of the helium gas. So they are talking about the internal energy in a gaseous sample. So the average kinetic energy means half mc squared of any molecule, of one molecule. We are talking about one molecule, is proportional to the absolute temperature of the gas. So this is basically talking about the temperature, and this is the average kinetic energy of one molecule. Okay, this is the temperature of one molecule, average kinetic energy of one molecule. So this is going to be our internal energy as well, because we are talking about not only one molecule, we are talking about 1.2 into 10 to the power 24 molecules. So if for one molecule the formula is 3 by 2 kt, then for this number of molecules it will be 3 by 2 kt into 1.20 into 10 to the power 24 molecules, because this formula is for only one molecule, and this you need to multiply it with this number of molecules. So it will be 3.2 into K is, what is the value of K? You guys need to memorize the value of K, because it is really important to be able to remember them. Okay, it's very important to memorize the value of K. (1.38 into 10 to the power minus 23 into 293 Kelvin. This is the temperature T. The overall value comes as 7280 joule. You can also write it down as 7300 joule. So basically this is our correct answer. So we are done with it. Okay, so the internal energy means the energy of this number of molecules, or the kinetic energy of this number of molecules in a helium gas. This is the kinetic energy of one molecule. So we have this number of molecules, so the overall kinetic energies added together will be the internal energy. Okay, so basically we are done with the question number 11. This is a very important question. I tried my best in order to make you guys understand, but still it is very important to understand the RMS speed, which is root mean square speed, and Maxwell-Boltzmann distribution graph as well. So make sure you are reading page number 123 and 124. This is internal energy part, exercise 8A from your physics student book 2. Please read that, otherwise you will be in big trouble in January 2025 or May 25, because I'm pretty much sure that there will be a question regarding this. Alright, so this is a thermal physics question which is more or less present in every physics unit 5 exam. So let's solve this question with a lot of determination. Now what we can learn from this is, we can say, let's say here I have taken a cold water. In this box there is cold water. Okay, so what I will do is I will pour some hot water into this cold water. I will pour some hot water into this cold water. Let's say I will pour some hot water into this cold water. So as I am pouring hot water into this cold water, the temperature of this cold water will decrease, right? No, the temperature of the cold water will not decrease, my bad. The temperature of the cold water will increase and the temperature of hot water will decrease, because at first let's say it was 85 degrees Celsius and it was minus 5 degrees Celsius. So when these two will mix, the cold water will become, let's say 40 degrees Celsius, and it will decrease down to 40 degrees Celsius. So we can say the temperature of hot water is decreasing and the temperature of the cold water is increasing. This is what will happen. Okay, this is what it will happen. Let's say this is not a cold water. Let's say this is an ice. Let's say this was an ice. If this was an ice, then what will happen is this water's temperature will decrease and this ice temperature will increase. But when the temperature of the ice will increase, the temperature of the ice will increase, first of all, before increasing the temperature of the ice will melt first. The ice will melt at first. After melting, then when it will become a liquid, at that time its temperature will increase. So while writing this type of answers, our first thing is we have to write one thing. That is, the first thing that is happening is, let's say the energy is transferred from the cooling, right? Energy transfer from hot water is equals to energy transfer to melt ice plus energy transfer to heat the ice water, right? This is the thing. The first thing, let's say here is a cold ice and here is some hot waters that we will pour in this. So what will this hot water do? The hot water's temperature will decrease and the ice temperature will increase. So As the hot water is poured into the ice will first melt. You cannot increase the temperature of the ice, right? There is no hot ice, there is hot water. Ice cannot be hot, so first this ice needs to convert it into water. So doing we are melting it. So this energy is transferred to melt the ice. That's why the energy transfer from hot water means this hot water's temperature is decreasing. So where is this energy going? This energy is using in order to melt the ice, and then after melting the ice we will increase the temperature of the ice. That's why how the formula is derived. I will do two maths for this type of question. Now let's read the question and solve it. They have said the 325 gram of hot water at 85 degrees Celsius is poured into a polystyrene cup bearing containing of 62.5 gram of ice at 0.0 degrees Celsius. So the degree Celsius of this hot water will decrease because it is using its energy to heat up this cold ice. So first of all it will melt this ice and then it will increase the temperature of the ice. They have said calculate the final temperature of the mixture of water and melted ice. One another thing is, as this hot water is poured into the ice, both of them will be in this container, so both of them will have the same temperature. So the final temperature of the mixture will be same. And the melted ice, they have asked the final temperature of the melted ice as well. So now let's go and figure the formulas. Okay, now let's go and figure out the formulas. So here the formula will be energy transfer from heat water, means the hot water's temperature has increased, so it has used some of the energies to melt the ice and then increasing the temperature of the ice or heat the ice water. So we can write the formula as mc del theta is equals to, first of all it has used this energy to melt the ice, so formula of melt is m of the ice into latent heat of fusion, which is mlf, plus the energy was also used to heat the ice water, so mc del theta. So here we can, let's do the math. We know the mass of the hot water as 325, which is in gram, which need to convert it into kilograms, so 0.325 into C, which is the specific heat capacity, which is we know 4190, which has been given in the previous part of the question. Okay, they will give you the specific heat capacity as 4190. As I'm doing one part of this question, I'm not doing the whole, that's why I'm writing it like this, into the theta value. How it will decrease? It was 85 degrees Celsius and this temperature will decrease, so 85 minus theta. And you might ask me a question right now, why I have written theta value after the 85? Because the theta value is small than the 85. The bigger value will always be in the first part, because the temperature cannot be like this. The temperature will be like this always, that the bigger value will be in the first part and then the smaller value will come. Into mass of ice, we know the mass of ice is 62.5, which is 0.0625, into latent heat of fusion, they have given is at 3.33 into 10 to the power 5. So this is our energy used to melt the ice plus the energy used to heat the ice water. The melted ice will be converted into the water, then this water will be heated, so we'll write the mc del theta. Now we will also use the mass of the ice, which is 0.065 into C, which is 4190, which we have written right here as well, which will be given in your answer in your question, into the change in theta. The del theta is this 0 degrees Celsius will now convert into a bigger value, because this temperature will increase. Now this temperature will increase, so theta minus 0, because this theta value is bigger than the 0 value, because it will become positive because the temperature will increase. Now what we have to do is we have to find these two theta values. As we have made this formula, now we have to find these two theta values. If you do this math and figure out the theta value, the theta value will come as 58.8 degrees Celsius. I'm not doing the workings today, just before 1 hour before the exam. You guys have to do the formula. The most important thing of making you understand is this formula, how this formula actually works. How this formula actually works is what we have to understand in terms of doing this type of questions. So we are done with the most important thermal physics question. I will also provide another thermal physics question solving to you guys, so that you guys can prepare in a much better way. Alright, so let's solve the question number 12 right now. Bronze is a mixture of tin and copper. Tin melts at a much lower temperature than copper. Okay, this is a very important information. The tin melts at a lower temperature than copper. 2.7 kg of solid tin at a temperature of 295 Kelvin is added to this mass of molten copper at a temperature of 1520 Kelvin. Okay, so basically that what is happening is the temperature of molten copper is much higher. Its temperature is much higher than the temperature of solid tin. So what will happen right here is when you mix something cooler with something much more hotter than it, its temperature increases, right? Let's say we are dissolving actually not dissolving, we are actually immersing. Let's say we are immersing ice cubes, we are immersing 2 ice cubes on a hot water. So these ice cubes temperature is much less than the hot water. So when these ice cubes will be immersed into this hot water, the temperature of these ice cubes will increase. Let's say the temperature of this ice cubes first of all will decrease. The temperature will increase. That which means the ice cubes will melt. When it has completely melted, and then the ice cube's temperature will start to increase. First of all it will melt, and then its temperature will increase. First of all it will melt, and then the temperature increases. In the meantime, the temperature of this hot water will decrease a little bit because its energy has been used to melt the ice cubes and then increasing the temperature of the ice cubes. So this is how we will do the thing. The thing is, the temperature of the molten copper is really high, so its temperature will decrease, and the solid tin first of all will melt. And then after that melting, then its temperature will increase. So basically these are the two important parts that we'll have to keep an eye on. So let's start solving this question paper right now. So basically the tin melts. They have said the tin melts and mixes with the molten copper to form molten bronze. Okay, they have asked us to figure out the final temperature of the molten bronze. So basically what we can write down right here is that this is the energy of the, I'm making you guys understand again, the energy of the hot water will be transferred to melt the temperature, to melt the ice cubes, and then increasing the temperature of the water from the melting of this ice cube. So what we can write here is that energy from copper, we can write energy from copper is equals to this energy. Let's say this energy for the ice, let's say this energy of the hot water or the energy from copper is equals to energy increased to energy to melt tin, plus, this is the melting, plus the increase in the temperature of tin, energy to increase the temperature of tin. So let's figure out each and every point one by one. First of all, let's figure out the energy from copper. This is the energy. So here we know that this energy will decrease a little bit. Why this? The temperature will decrease a little bit. Why the temperature will decrease? Because the molten copper will use its heat energy to melt the solid tin and then increase the temperature of the solid tin. So by this term, this temperature will decrease, and it will decrease to a theta value. The value we don't know. So we will do that. We will do the formula. This will be is equals to mc del theta. Energy from copper is equals to mc del theta, which is equals to the mass has been given as 10.5 kg into the C heat capacity of molten copper is this 572 joule kg per Kelvin into the del theta. The del theta means this 152 will decrease to a value. So we will write 152 0 Kelvin minus the theta. Some guys have a question why I have written this theta value after that, because this theta value will be lower than this value. That's why we always write the higher value in the beginning and then the lower value in the end. Okay, so we are done with mc del theta. This is the value that comes. If we equate them, we will get a value like this, 9.13 10 to the power 6. If we multiply these two values and then it with this value, which will come as this is the theta. This theta is very important. This is what we are actually going to find. So now we have figured out the energy from copper. Now what we can do is we can figure out energy transferred to tin, because this energy from copper has been transferred to the tin. So we can take these two values together. Okay, so let's take them down. Energy transferred to tin is equals to this energy which has been used to melt the tin will be used a latent heat of fusion. So we will take the mass 2.7 into LF. So 2.7 into 5.92 into 10 to the power 4 joule per kg, and here we have to write the kg as well, plus now as we have added the energy to melt the tin, now we will add the energy required to transfer the to increase the temperature of this tin, to increase the temperature, which will be denoted as mc del theta, which will be denoted by mc del theta. So the mass of the tin is 5.92 into 10 to the power 4 joule. Sorry, this is the specific latent heat. We are looking after the mass of the tin, which is 2.7. 2.7 into the C, specific heat capacity of tin, which is 214, into, we know it had our theta value, and then it will decrease. Sorry, its temperature will increase. So its previous value was 295, so its value will increase to, let's say, a theta value. It will increase to a value of theta, and we know this theta value is greater than this 295, so we will put this ahead of that value, which is theta minus 295. We always add the bigger value first. After writing them all, now what we have to do is we have to just multiply this part and then this part. These two part will be multiplied. If we multiply this part, what we will get is 2.7 into 5.92. This comes as actually we can do the whole thing together. After doing the whole thing together, what we will get is we will get 1.00 into 10 to the power 4 joule plus 578 joule per Kelvin theta. This is the value that we will get after adding these two values. After adding those two values, we will get that value. Alright, so previously we have figured out the energy transferred from copper. This was the energy transferred from copper. And we know the formula energy transferred from copper was used to melt the tin, and then with addition to that to increase the temperature of the tin. So we have multiplied this energy transferred to measure energy transferred to melt the tin plus energy transferred to increase the temperature of the tin. So these are the two values that we have got. So we know they are equal, right? So we can write this value equals these two values, and then we can figure out the value of theta, which was the main question of the main question. Okay, so now let's go and figure that out. We can write according to this formula that we have previously written in the black marker. Energy transferred from copper is this, so we can write 9.13 into 10 to the power 6 joule minus 6 into 10 to the power 3 joule per Kelvin. This theta is equals to 1 into 10 to the power 4, this value, plus 578 joule per minus Kelvin theta. Okay, for not being confused, we can remove this joule part, and we can only consider these theta values, because this joule part are making things confusing. So you can also write it down as 6 into 10 to the power 3 theta. These are equal values, these are together as well. Now we have to make theta the subject and figure out what the value of theta comes as. Actually the value of theta comes as 1386 Kelvin. So this is our answer, which can be written as 1390 Kelvin in the final answer. So basically in this question, while solving this question, I didn't show all the workings because you guys are now in A2, and I think I don't need to show workings anymore because you grew up quite well. So this is the thing that I have figured out this value without showing the workings, and I didn't also show workings here. Figure out the value of theta as 1390. So please figure it out by yourself, and if you can't, then please practice how to figure out values. Otherwise, if I have done this by myself, then you would have never done this by yourself, which is very important in physics unit 5. Students a lot of times know how to do the math, but they don't become successful in terms of doing the math because they mess up in the calculation part. That's why I didn't show the whole. Alright, so let's understand this question. They have said this is a very repetitive question, so let's understand it and answer it. This is a 6-mark asterisk question, which is really repetitive, and I believe that this will come in your exam as well. The pressure inside a football decreases as the temperature of the air inside falls. While solving this type of questions, what we will do is we will write PV is equals to NKT, this formula. They have said as the pressure decreases, the temperature decreases. This is what they have written, right? So we know temperature should always be linked with the kinetic energy, because temperature and kinetic energies are directly proportional. So as the temperature has decreased, the kinetic energy is also decreased. We have to mention that thing. As the temperature of the air decreases, the average kinetic energy of the molecules decreases. And we know when the kinetic energy decreases, kinetic energy should always be linked with P square by 2m formula. So when the kinetic energy decreases, the average momentum of the molecule will also decrease. This is the part. That means the kinetic energy decreases, the average momentum of the molecule is decreasing. Now as we have moved toward the average momentum of the molecule, let's say this is one part of the container and this is another part of the container. One molecule is going in this direction and colliding with the container of the wall. Now if the average momentum of the molecule has decreased, when it will collide, it will bounce back, right? But the bouncing of but it will bounce back with a lower velocity. It will bounce back with a lower velocity. So we can say the change of momentum during a collision with the container wall decreases, because at first it collided with a higher velocity, but then it is coming back with a lower velocity. So we can say the change of momentum of a molecule during a collision with the container wall decreases, because the change of momentum is not that bigger like the earlier ones. Now as the change of momentum had decreased, the rate of collision rate will decrease. It will collide with the container wall less number of time in a given period of time. In a given period of time, let's say it used to collide 10 or 15 times with the containers of the wall. Now the rate of collision will decrease. It will collide 5 or 6 times with the container of the wall in a given period of time. So we can say the rate of collision of molecules with the container wall decreases. Now as the rate of collision has decreased, we can say the rate of change of momentum has also decreased. The change of momentum has decreased, as well as the rate of change of momentum has also decreased. So we have to mention these 2 points. Why the rate of change of momentum has decreased? Because in a given period of time it is colliding less number of times, so the change of momentum is not increasing that much. The change of momentum has, on the other hand, decreased. Now here comes the 6th point. The 6th point is, as the rate of change of momentum has decreased, okay, now the pressure will also decrease, because the force has decreased. We know pressure is equals to force per unit area. As the rate of change of momentum has decreased, now it will collide with the container wall with less amount of force. As the force has decreased, we can say the pressure is also decreased, because the pressure exerted by the gas decreases since pressure is equal to force per unit area. As the force has increased, the pressure is also increased. And why did the force decrease? Because the rate of change of momentum is equals to 4. We know force is equals to mv minus mu divided by time taken. If this rate of change of momentum has decreased, then this force will also decrease, and if the force decreases, then the pressure also decreases. So we are done with the 6 points. Please kindly memorize it by understanding. If you don't understand, if 1 or 2 points, still memorize and write it down in your exam if the question come like this, because this is a very repetitive question. Alright, so let's solve this question as well together. The reason behind picking this question is, in this type of question we have to do ratios in order to figure out the answers. So this type of questions are really important, where one is multiple times of the other ones. So let's read the question. They have said Betelgeuse is a red giant star with a luminosity. Okay, they have given us the luminosity of Betelgeuse, and they have given us the peak intensity of radiation from Betelgeuse occurs at a wavelength of this. Okay, they have given us the wavelength of the Betelgeuse. They have given that a website claims that the radius of Betelgeuse is 1000 times the radius of the sun. So this type of questions are very important, because here they have written about the multiple times, that one is multiple times bigger than the other ones. They have also said assess the accuracy of this claim, and they have given us the surface temperature, and they have given us the luminosity as well. They have given us the surface temperature and the luminosity of sun. Previously they have given us the luminosity of Betelgeuse. Now they have also given us the luminosity of sun. So let's solve this question together. Now they have asked to find the radius of Betelgeuse, whether it is 1000 times than the radius of the sun. So to find the radius, they have given us the luminosity of the Betelgeuse and the luminosity of the sun. So first of all, let's write the formula of luminosity. One of the formula of luminosity is 4 pi r squared sigma into temperature to the power of 4. Now we have got the luminosities. 4 pi is a constant. We have to find out the radius. Sigma is the constant. In order to figure out them all, we have all of them except the temperatures. We have to figure out the temperatures in order to be able to figure that out. We have the temperature of sun as well. We just need to figure out the temperature of Betelgeuse, and in order to find out the temperature of Betelgeuse, they have given us the wavelength of Betelgeuse. So let's use it to find out the temperature. We know lambda max T is equals to 2.898 into 10 to the power minus 3. Now the temperature will be 2.898 into 10 to the power minus 3 divided by the lambda max. They have given us the lambda max as 850 nanometer, and you need to convert it into meter. 850 into 10 to the power minus 9 meter. Now we will get our temperature, which is 3410. This is the temperature of Betelgeuse. Okay, we have got the temperature of Betelgeuse, and we have the temperature of sun as well. Now as we know that the radius of Betelgeuse is 1000 times the radius of the sun, so we will take which one is bigger. The radius of Betelgeuse is bigger. We will take the radius of Betelgeuse, or the luminosity of Betelgeuse, in the numerator. So what we'll do is we will write it like this. The bigger one will be in the numerator, the luminosity of B divided by the luminosity of sun, as the luminosity of B is bigger. So we'll write the formulas: 4 pi r B squared temperature B to the power of 4, and the sigma will be right there as well. 4 pi r squared sigma, this is the sun, and this is for the temperature of the sun, into 4. This is how we will write it down. Now out of this we have all of them, right? We have all the values. We have the red, we have the luminosities, we have the 4 pi, we have the radius. We have to figure out the radius, we have the sigma, and we have the temperature. So we have to make radius the subject, because we are talking about the radius. One's radius is bigger than the other ones. So if we make radius the subject right here, radius of B divided by radius of sun squared, both of them will be sun squared. Now what we can do is, this is LB into these ones. All of these ones will go right here. So 4 pi r squared into sigma into temperature to the power of sun to the power of sun. This is the temperature of the sun, divided by all of these values will come right here. So luminosity of sun into 4 pi r, sorry, 4, no, the r will not come right here. Sorry, my bad. Here the r will not come. The r will not come because the r is right here. only the 4 pi part will come. Only the 4 pi part will come. 4 pi into sigma into temperature to the power of 4 of the Betelgeuse, because the Betelgeuse has come here, right here. Okay, so we have derived our formula. Okay, now we can take away this radius by root overing them overall. So we can take out this radius by root overing them all. So we can take away this radius. We can take away this radius and root over them. So root overing them overall will take out the radius. So now our formula is RB divided by RS is equals to root over luminosity of B into 4 pi into sigma into temperature to the power of 4 of the sun divided by luminosity of B into 4 pi into sigma into temperature of Betelgeuse to the power of 4. Now if we put everything right here, we will get the answer. So let's put it right here. It will be like this. Now what we can do is we can remove all the constants. This 4 pi sigma is a constant, this 4 pi sigma is constant. So the formula will be radius of B divided by radius of sun is equals to root over luminosity of B divided by luminosity of S into temperature of S to the power of 4 divided by temperature of B to the power of 4. Here it was in divided form, right? We have just made it, both of them were in divided form. So if we take out the multiplication, we have to move the denominator to the numerator and the numerator to the denominator. That's why we have made those changes. Sorry, my bad, it was multiple before as well, so we didn't need to take the changes. We have just removed all the 4 pi 6 because they were constant for both of them. We have just LB into TS4, LB into TB4, we have written like this. Now if we put all the formulas right now, it will be, let's write the formulas right here. Let's write the formulas right here. That it will be root over 4.49 into 10 to the power 31 divided by 3.83 into 10 to the power 26 multiplied by 5800 to the power of 4 divided by 3410 to the power of 4. So the value comes as 991. So RB divided by RS is equals to 991. So we can say it is not 1000 times, it is less than 1000 times. So we can say the claim is incorrect. The claim is inaccurate. So this is how we will do this type of ratio maths, which are really important in physics unit 5. I have shown one, but it might come in your exam in a different way. So make sure you're understanding it by heart and practicing it before your exam, just 1 or 2 hours before your exam. They have given us the force time graph. So come on, let's read this question right now. What they have written. They have written the graph shows how the force varies with time for an object performing simple harmonic motion. They have given us the force time graph. They have given us 4 examples and asked us to figure out the displacement of the varies with time. Okay, so is it a force time graph? We can also refer it as an acceleration time graph as well, because we know force is equals to mass into acceleration, and force and acceleration is directly proportional. So both of their graph will be more or less similar. And another thing that I want to make you guys understand is F is equals to minus kx. Okay, the graph of force versus time is out of phase with displacement by pi radians. Okay, we don't need to know about the pi radians at the moment. What we can actually do is this is a sine graph, right? This is a sine graph. If this is a sine graph, if force is a sine graph, then the displacement will be a negative sine graph. Will be a negative sine graph. Will be a negative sine graph, but exactly the same. It will start. It is starting from here and going like this. It will be like this. The graph will be like this. So basically, D is our correct answer. According to F is equals to minus kx, the displacement is negative of the force. So we can say this graph will be a negative sine graph. So our correct answer will be D. Now moving forward, they have asked about the velocity. They have asked us about the velocity. So we know velocity is the derivative of displacement. Or we can also say one thing. Let's erase that part and write it down like this. when something is in simple harmonic motion, when something is in simple harmonic motion, when the displacement is maximum, at that time velocity is 0, and when the velocity is maximum, okay, at that time the displacement is 0. When the displacement is maximum, the velocity is 0. When the velocity is maximum, the displacement is 0. So here, when let's say take this graph. This is a VT graph, right? Sorry, this is the displacement time graph. So if the displacement is negative, if the displacement is 0, the velocity will be at max. Okay, the velocity will be at max. And when the displacement will be 0, sorry, when the displacement will be maximum, like this, here when the displacement is at maximum, the velocity will be 0. So basically graph B corresponds this thing right here. Let's say right here, when the displacement 0, the velocity is at maximum. This is our VT graph. When the displacement is 0, the velocity is at maximum. So basically graph B corresponds to that thing. So we can say 10 is our answer for displacement and time graph. If you have given the displacement graph and you have asked to find the velocity time graph, you have to look one thing, that is, when in the displacement time graph the displacement is 0, at that time the velocity is at maximum. When the displacement is at maximum, the velocity is at 0. So B is our velocity time graph. A similar question has arrived in the October 2024 paper as well, where I have solved this question in a very detailed way. Still I will solve it right now so that you guys can go through it just before your exam, or just 2 or 3 hours, or just 6 or 7 hours before your exam, and revise them, because this is a very important question and it might be in your exam day as well. So please go through the October 24 paper as well. There is a more detailed explanation, and there is also some more questions as well regarding this. So basically what they have said right here is a particle is undergoing simple harmonic motion. Okay, very good. They have given us the VT graph. They have given us the VT graph of the simple harmonic motion. In the VT graph they have given, and they have asked to write the displacement time graph. We know speed is equals to distance divided by time taken. Okay, speed is equals to distance divided by time taken, and distance is equals to speed into time. In simple harmonic motion, specifically for simple harmonic motion, when the speed is 0, at that time the displacement is maximum, and when the displacement is 0, the speed is maximum. This is one thing that you guys need to memorize or remember for simple harmonic motion. When the speed is 0, the displacement is maximum. When the displacement is 0, the speed is maximum. Here, when the speed is 0, at that time the displacement must be maximum. For that reason, this is not maximum. Our A cannot be answered. Our C cannot be answered, because the displacement is also 0. This displacement cannot be 0. Displacement needs to be maximum when the speed is 0. Here, when the speed is 0, the displacement is maximum. That's why this is our correct answer. Here, when the speed is as maximum, the displacement is minimum. That's why this is our correct answer. The correct answer is B. We are done with this paper as well. The simple harmonic motion of displacement time graph. And another thing is, when it is positive, it will be a negative graph. When it is negative, it will be a positive graph. And in the D part, the displacement and the speed, both of them are positive. So that's why, just because when the speed is 0, the displacement is maximum, but it is in the positive line. It cannot be in the positive x-axis. It needs to be in the negative x-axis. That's why B is the correct answer and D is not the correct answer. So we are done with this question as well. All right, so these are the three FAQs that might come in your exam that I am predicting that it will definitely come. One of them is trigonometric parallax, which is a 4 marks question. If you don't know how to answer it or you don't understand it, you don't have time left for them to understand right now. It's better to memorize it, because it's the same question that every time comes. If they ask you to how to calculate the distance to nearby stars, how astronomers use parallax method or Ovel's trigonometric parallax to calculate the distance to nearby stars. When they mention distance to nearby stars, then please write the first 4 points that I have written for you guys. And they ask how astronomers determine the distance to distant stars, not the nearby stars. The nearby stars for the first one, if they ask about the distant stars, then write the second answer that I have written, which is also a 4 marks question. And another very repetitive question of 2 marks, which is the definition of or condition of simple harmonic motion. So these are the 3 questions which you should memorize before going to the exam, because it might come. And now let's go through some of the more repetitive questions which may come. These are the frequently asked questions that comes in physics unit 5. So please memorize all of them and take a screenshot. There's another very important question, the stellar evolution, the evolution of the sun, the evolutionary phases of the sun with reference to the HR diagram. This is a 6 marks question which maybe will be in your exam today. So please memorize it as well before going to the exam.